Good morning to one and all present here. This is Padmavati. I'm working in Sri Venkateshwara College of Engineering, Bangalore, in the Department of CSE. Today we are going to see about digital image processing. Digital image processing comes under three COs. The entire course covers in three COs. CO1 is nothing but it defines the basic concepts in image processing, and CO2 it evaluates various techniques which is used in image enhancements, and CO3 which shows various examples of image segmentation and compression algorithm. So before proceeding into image processing, we'll see what is an image. Image is nothing but a two-dimensional data. So it consists of x and y, and an image can be represented as f of x comma y, where f represents the amplitude and x comma y represents the intensity of the gray level of the image. So now we'll go to digital image. What is the difference between an image and digital image? We'll see. See, if we take any image and that image can be processed using a computer, that means it is called as digital image. That means you are processing an image using digital computer is called as digital image processing. And the image comprised of pixels. See, you can able to see the dots, which is nothing but various pixels. That means image consists of pixels, or image comprised of pixels. Image pixels in the sense pixels has various names such as picture elements, pels, image elements. That pels is nothing but it's a short form of picture elements. So pixel consists of the image values. The image details will be held in pixels. And here I have just represented this image in matrix form. See here, f of 0 comma 0, f of 0 comma 1, f of 0 comma n minus 1. That means this means it is 0th row and 0th column. This is 0th row and first column. This is 0th row and n minus 1 column. In the similar way, f of m minus 1 comma 0. This is m minus 1th row and 0th column. This is m minus 1th row and this is first column. This is m minus 1th row and this is n minus 1 column. So here again I'll be telling about some pixels. See, in digital image it composed of finite number of elements which has a particular location, and this particular location you can able to see here. See, if I want to calculate this particular point, and I need to calculate it is first, second and third row, and this is third row and third column. So if I calculate this particular point, which is nothing but third row and third column, if I want to calculate this, then it is third row, fourth column. And if I want to calculate this particular point, it is third row and fifth column. So likewise, you can calculate the value of value or the details that holds in the pixel values. There are various steps in digital image processing. Various steps are there. Those steps are called as basic fundamental steps in image processing. So let's see what are all the various steps in image processing. First one is image acquisition, which is nothing but capturing an image. How we are capturing an image using digital camera or scanner, or some already taken pic or photo from where we are capturing that image. So that process comes under image acquisition. And image enhancement is nothing but here various parameters are there: contrast, hue, saturation, brightness. All parameters will comes under image enhancement. And image restoration is nothing but, suppose if any noise or anything will be added in your image, if you remove that noise, so you can restore the image in a particular format or in a particular position. So that is called as your image restoration. And color image processing. So when I tell about color, the basic primary colors are R, G and B. So that is red, green, and blue. So all these three colors, uh, what it holds, the value of the image. That means you can enhance R, or you can enhance G, or you can enhance B, or mixed uply you can just enhance all those images. So that is called as your color image processing. And next is nothing but wavelets. So here basically we all know Fourier transform and discrete transform, continuous transforms, and all we know. Here there are various wavelets are there, each having its particular and peculiar function for different types of applications. So we can apply wavelets for different kinds of applications. So what are all the wavelets are there, and for which kind of applications it was used. So all those things we can see in this wavelets. And compression, see, this holds a very important in engineering process. See, normally in day to day life also, if we want to compress a data, we use a compressor. See, what is basically a compression? Compression is nothing but, if you have a big size image, that big size image you are reducing the size, and after reducing you can transmit to any channel. So that is called as compression, and this compression technique is used in different fields like cryptography, communication, and wireless, Bluetooth, everything you can use this compression techniques. And then is morphological processing. See, if you want to cut down some portions of the image, so you can do all those extra modifications in your image. Those things and all will come under morphological processing, and here you are having various techniques in morphological processing. So based on the technique you can use. And segmentation, next is segmentation. Segmentation is nothing but, you are, if you want to take an if you want to pick an object from an image, that is, you want to extract an object, segment is nothing but taking out or picking out or cutting out from that an entire portion. So that is called as segmentation. Segmentation is basically separating an object from its background. It is called segmentation. And next is representation and description. So after segmenting an image, after segmenting an object from an image, what you are going to represent that image or that particular object. So those things and all comes under representation. And next is object recognition. See, how we are going to recognize an object in an image. Either you are going to the same like if suppose for example in an image, if you are having two different balls are there, so you want to recognize an object as one, or you want to make it as two different classes. So those things and all will comes under object recognition. And the basic thing, that is image acquisition, we are going to see one example. See how the image will be captured as a human body through our eyes. Through our eyes, we are recognizing an image. See, this is nothing but the human structure of our human eye. See, there are various spots have been given, which is called as retina, sclera, choroid, blind spot, ciliary muscles, lens, cornea, iris, and visual axis, vitreous chamber, fovea, ciliary muscle, and anterior chamber. Everything is there. So, what is the basic function of human eye? We are going to see. See, in the basic function of human eye, whenever you are seeing an object, that image it will take in the inverted position of an eye. Suppose if an whatever the image in front of your eye, whichever you are seeing at the back of your eyesight, then it will be the inverted image. So in this way, we are capturing an image and we are going to do the modification process, and we are going to understand how an image can be modified using different algorithms. Those things and all we are going to see. Thank you.